Hello, everybody. Welcome to RubyConf. This is a talk about Sorbet, the type checker for Ruby 3 that you can use today. I'm Dmitry Petrashko.
I'm Jake Zimmerman.
Yep. Thank you for coming here. Here is the outline of this talk. First of all, we'll run you about some of the background in which this type checker was created, which problems did it exist to solve, and why did we believe that this is the right solution for them. We're followed by discussing the today reality of this, about how the community is using it today, how other companies are benefiting from it, and what is waiting for us in Ruby 3. So first of all, what is Stripe? We're coming from Stripe, which is a company that's helping other people run businesses online, helping them focus on building their products by making it easier for them to facilitate payments on the internet. Stripe has more than 2,000 employees. We have engineering hubs in San Francisco, Seattle, Dublin, and many other cities. We're hiring interns full-time. We're also hiring remotes. Please go to stripe.com/jobs and see the open positions there. We, more specifically, are members of Stripe Developer Productivity Team. We're the teams who's helping engineers have the most productive life of their career at Stripe. We help them focus on building the product rather than in overcoming obstacles which are specific to development. And Stripe, more specifically, uses Ruby a lot. Ruby is our main product language, and thus, as developer productivity team is helping Stripe engineers be more productive, we mostly end up working in Ruby and mostly end up building better Ruby abstractions for Stripes. Thus, our customers of mine, are internal Stripe engineers. There are hundreds of them. They're writing millions of lines of code in a single repo. That's intentional. We're intentionally we want it to be easier to make changes, to make swapping changes around the entire code base. And thus, we have a single repo with tens of millions of lines of code. And there are thousands of changes that happen in this repo every day, done by all of those engineers. In order to do our own prioritization, in order to figure out what do we do to make our engineers more productive, one of the ways we learn what are the things worth improving is by asking them. We run something that we call Developer Productivity Survey, where historically, before Sorbet existed, a common feedback that we've heard was that for engineers, it was taking a very long amount of time to get feedback from existing systems of whether their code is correct. It took too long to grasp the unfamiliar code, to read the code of some other teams or previous people who were in their team. And the code base was pretty fragile. It was very easy to break the things. A lot of assumptions were unspoken in the code. And by doing it slightly differently, it was possible to break the things without noticing it. So we went to assess what were our options to improve on the situation. The first option is, well, do nothing. Ignore the feedback and let the engineers cope with the situation. The downside here is engineers will be less productive. They will continue facing this complexity of the code base, the brittleness, and the increasing iteration cycle. We didn't want that. The alternative was to treat the symptoms of existing code. We can go and find the biggest offenders and go and manually fix them. But as the company is growing, we believe it will be increasingly harder for us as a single team to do this manually. So we didn't choose this option either. Another option was just declare bankruptcy and rewrite the thing. Rewrite it to make it perfect from start. This is a high risk. We'll have to have hundreds of engineers that will be rewriting our product. During that, we'll have to maintain both of them. And maybe it will succeed or fail, and it's all or nothing. It either entirely succeeds or entirely fail, so it's a high risk. Another option was to rewrite some things. Take 10 engineers and write the horrendous offenders and make the things that matter good. Well, the question about the things that matter is very hard to agree what matters long term. You might be wrong, because some things that used to matter no longer matter, and some things that used to not matter now. You may be launching new products. You might be opening new directions. You might be changing priorities, and might be there are some pressures that are making the area that used to not be important now more important. So it's a hard decision to take. And similarly, it requires a substantial amount of engineering. It requires tens of engineers to rewrite the thing. And finally, the one that we chose. We chose to write a type checker The good thing about type checker is this is a tool. This is not a process that you need to do. This is a tool that you do, and the tool works on everything. So what we did, we started a team with 3 engineers, which is, as you see, the smallest investments between all of those, which was able to deliver incremental value in a month. Every improvement was possible on a file-by-file basis. Improvements came every day, rather than requiring a leap of faith, and a lot of engineers committed to this leap of faith. So that's why we built the type checker for Ruby. Here's a timeline. In October 2017, the project was kicked off. Originally, we've been evaluating a few other alternatives. Notably, we evaluated the typed Ruby, the type checker for Ruby built by GitHub. That's now open source, and we ended up not using it, but we took the parser from it, and it's pretty good. We also evaluated RDL, which was built by Jeff Foster, who is doing research in typing Ruby. But unfortunately, it was too slow to work in our code base. It would have taken literally hours to do a single type checking run there. So it would be slower than our test suite even. So because of this, we decided to implement our own thing. In February 2018, we typed first production call in real world. We took a substantial piece of our code base, and we ourselves, as developers of the tool, were verifying whether our tool actually is useful by taking real code and trying to type it and seeing that error messages make sense. And to be honest, at first they didn't. At first, those error messages were complaining too much in some cases, where the code is correct, but it doesn't like it. It wants you to follow some scheme that you may disagree with, and you're probably right. Why is this still forcing this on me? And in other cases, it was permitting things that we didn't want it to. So this is a moment which we believe contributed the most to the experience of using Sorbet. We've been intentionally building on a balance of allowing users to write the code that they want and checking the things that are unsafe there. We want the users to feel like this is a helper rather than the guard that's prohibiting them from something. And the manifestation of this was in June 2018, where we made this required for every engineer at Stripe. And at that moment, when it became enforced on everybody, this was a moment where we were very careful to make sure we're here to every engineer. Because if somebody has a pushback, if somebody doesn't like it, we want to make sure that they feel heard. And if the tool actually is not working for them, we should go back to the drawing board and fix something. Fortunately, it worked really well. Majority of people liked it. Some people were neutral for quite a time, but then as we were developing more and more features that they cared about, they got on board. And a year later, in 2019, after an extensive beta with more than 40 companies, it was open source, and now it's available for everybody to use. So I want to dive deeper in what problems did we want Sorbet to solve, and how does it solve them. Jake?
Thank you, Dmitry. All right. So we're going to dive into what problems Sorbet actually solves in a real code base. So going back to Dmitry mentioned this developer productivity survey that we run at Stripe, and there were kind of 3 repeated kind of complaints or concerns that people raised over multiple iterations of this survey, which were it took too long to grasp unfamiliar code. It took too long to get feedback after having changed the code, whether that's writing tests or whether that's seeing the results of it in production. And then, having changed it and gotten the initial feedback, it was still too easy to accidentally break things. Well-meaning developers were, people get paged, and that's something we as developer productivity try to minimize so that we can, make them more productive, focusing on actual product, not fixing a broken product. So as an example, diving into that first point of what I mean by it took too long to grasp unfamiliar code, I pulled this snippet almost verbatim from Stripe's code base. I've shortened some variable names, but we've got this method here. It says find card similarity. And so consider that we're trying to debug something. Maybe we came here because we saw a reference to this location in a stack trace, and we're like, OK, what is going on with this code? Why is there a problem here? And so it's our task to understand it. But we really have no tools to figure out what's going on here. The first question we might ask about this code is that merchant argument, is that a string ID of a merchant's unique ID? Or is that an actual object that's some model instance? And we can't actually tell, because it's just being passed on to 2 other functions. We're not interacting with it in any way, so it could be one of either, which means if we wanted to change this code and we wanted to access some property on a merchant, we don't know whether we have to first load the thing from the database or whether we already have it from the database and we can just access its fields directly. Another question that we might want to ask here is, OK, we can see that the result of this similarity db.fetch call is returning some data, but the previous programmer thought that it might be null. Is it actually going to be null? Like, what does it mean for the result to be null? We're kind of coding defensively here and sticking this like or equals of an empty array, but like, is that necessary? Is that silencing some condition that we should actually be handling completely differently? Like, we have really no knowledge into what this code is doing. And the kind of point here is like, we've taken a simple example, and maybe it's kind of trivial, but this happens all the time. And especially when you're working with an engineering organization the size of Stripe's, where you've got hundreds of engineers making thousands of changes per day, the chance that you encounter unfamiliar code is like, it's inevitable. Like every day you're looking at code that is unfamiliar. So that second point that came up in this survey was it took too long to get feedback. So here are some numbers. Like if Stripe very, very, very strongly believes in test-driven development, and so we write tons and tons of tests because Stripe as a payments company is involved with actually moving people's money around, and so we want to make sure that we're doing that correctly. So over the years, we've written so many tests that if you tried to run every test that Stripe has on a single laptop, end to end, it would actually take days of wall clock time to run those tests. So of course, as a developer productivity organization, we've done a lot of work to make these tests run in parallel with like really, really powerful CI, and so that you can get results really fast. And so like those tests take anywhere from 10 to 20 minutes. And recently, we've done really impressive work to get it down to like 8 or 6 or 5 minutes, depending on the kinds of changes you're making. But that's still 5 minutes where we're just waiting to see whether the change that you made is the right change. And we really want to measure ourselves based on how fast people can actually change the code. People can type a single key inside their editor and see it render on the screen in milliseconds. So why should we not measure ourselves and aspire to give them feedback that quickly? So that's kind of what we're trying to get to in terms of too long to get feedback about the code. And then the third is it's too easy to accidentally break things. So going back to this snippet from before, let's say that we identified, OK, it actually is a string, but I need it to be a merchant. So let's change it, but what are all of the places that I need to update? And that could be, maybe this method, it has a particularly unique name, like find card similarity, probably doesn't show up in a lot of other places, but that's not always the case. Sometimes these methods, you can't just grep for them. You can't just figure out where they're being used. Maybe you can run the tests and see which tests fail, but sometimes that doesn't catch everything. So is it enough if the tests pass? Is it enough if you make the change and then deploy the code and see that production says that there is no errors? Like at what point can we be confident that the change that we actually did make was safe? So those are the kind of the problems that we're trying to use Sorbet to solve. So at this point, we built Sorbet, we deployed it, every Stripe engineer is using it. Looking back on those year or 2 years of using Sorbet at Stripe, has it fixed these things? And so rather than answering that question directly, I'd rather just go to a demo. So you guys can almost follow along. You won't have the starter code that I will have, but we've built an online sandbox for Sorbet called sorbet.run. So anybody can go there in your browser right now and mess around with it. Another fun thing is because it's running in the browser, I can embed it in an iframe. So I can just poke around right here. So here is our code snippet from before. The first question that we were thinking about was that it took too long to grasp unfamiliar code. We were not really sure what this function is doing. So all we have to do with Sorbet is to point and click, or not even click really, just point. And you can see that Sorbet.
You should be pointing on the other screen.
Oh, you're right. I am pointing on my local demo. Thank you, Dmitry. So the first thing that you can do, hover. Cool, all right. So the first thing that you can do is you can hover over the name of a method and just immediately see the type for this method. You can see also the documentation for this method. You can see the question we were trying to figure out before was merchant a string or was it an object? We can see directly there, it's a string. If there wasn't, sometimes there's documentation, sometimes there isn't. If there wasn't documentation and we really just wanted to check the implementation out, we can right click and say go to definition, and then we see that we jumped right down here to my definition. Of course, this is a little demo, so I've unimplemented it. In PayServer or in Stripe's code base, this is actually implemented, but we'll ignore that for now. So that's immediate, right? That feedback is just point and click, and people can figure out this code that's unfamiliar to them and get grounded in the reality of it, and then move on and think about the problem they were actually trying to solve. The next, oops, my cursor is over here. The next question we had was like, you know, having changed the code, what is the fastest feedback that we can give people as to whether they've done it correctly or not? So I'm just going to go over here and like, you know, introduce an error for the sake of making an error. And you can see those red squiggles update as soon as I type something. And so Sorbet can point directly to the parts of your program that are wrong as you're typing it. So you don't have to wait for this test run to say, oh man, I've typoed this method name. I need to go rerun all the tests after having fixed it. And again, as you type things, not only can Sorbet tell you what's wrong, but it can suggest to you how to fix it. So here I type like the name of this method, and Sorbet immediately pops up a completion item that says, well, maybe you meant this. And not only will it say, like, it's kind of small, but it's suggesting me the fetch method that's on this object. Not only is it suggesting me the name of the method, but if I ask it to show the documentation for that method, it will do it. And so again, we see that same documentation we saw earlier, where it's telling me the type of this method and what the documentation is for it. So if we type tab, then it'll go and let us fill in the blanks for all the information that it needs. And so we can go over here for merchant, and it'll suggest merchant, and so on and so forth, right? And so that's feedback that, like, this demo, that it's, again, running in an iframe in a Reveal.js presentation, but let me assure you that this is actually as fast as it is in Payserver's, Stripe's multi-million line Ruby code base. And that's partly due to, like, some really interesting architectural decisions where, like, Sorbet can see that you're only editing inside of a method. So certainly, it only needs to analyze that method and so forth. So we've done lots of really interesting technical things inside of Sorbet to be able to give this feedback to developers as quickly as we can. The last thing is we want to make it kind of harder, not impossible, but harder to accidentally break the code. So the way that Sorbet does this is by giving people one more tool to analyze their correctness. So having grappled with this unfamiliar code as a developer, now we want to go in and leave our understanding behind for future engineers so that when they come in next time, they won't have to know whether this thing is a merchant ID or a merchant object. They can just see it. So the easiest way to do that is by leaving behind a type annotation for this method. So we can write a type annotation for a method in Sorbet by typing SIG, which is like method signature. And so like if we start typing that inside this editor, not only will Sorbet show us that sig is a method we could call, but it will also show us a suggested sig for this method. And so what we can see here is that just by typing out the start of a type annotation, Sorbet says, hey, it looks like you could add this type signature for this method. And in fact, like, it's actually right in this case. The parameters that it says is a method that's going to take a merchant, which is a string, and it returns some similarity record object, and all we have to do is press tab, and that signature just pops into our code. And so we didn't even have to think, in this case, about what the type was, which gives us a great starting point if we want to change this code, because now Sorbet will update its knowledge of the world to say, like, it must be the case that this signature is true. So if we wanted to change it, like maybe the change we wanted to make was to change this from a string to a merchant object, as soon as we finished typing that signature, Sorbet then updated its knowledge and said, OK, it must be the case that this is a merchant object. And so if you are ever using this local variable in a way that was incompatible with that, it'll show you all of the errors. And I can't show this because it's inside of the browser, but like in VS Code, there would actually just be a separate tab where you can just list all of the errors and just jump to def, jump to def, jump to def, and just fix the errors. So we can, we could hover over this and see what the error message is. It says expected string found merchant object for argument merchant. And so now we can just go through and, again, this is one more way to be, a little bit more confident that the change that you've made doesn't silently break something. It's tests help, deploying the code helps, also type checking the code helps. And so that's kind of one more way. Cool. So let's click out of here. So again, those are the three kind of benefits that we talked about, where the types make the code easier to grasp, especially for unfamiliar code. Sorbet is as fast as you can type, so you get feedback much more quickly than other alternative methods. And Sorbet ends up being one more tool to help developers analyze and reason about whether the thing that they've written is actually what they wanted. Cool. So that's kind of the demo of like the problems Sorbet was trying to address and whether or not it solved them. So now I'm going to hand it back to Dmitry, who will talk about the growing Sorbet community since we've open sourced Sorbet.
Thank you, Jake. So as was discussed earlier in the timeline, it has been slightly less than a year since we open sourced Sorbet. And since even before we open source Sorbet, we had an ongoing discussion with Ruby core team about what should be happening with this. And as Matz announced at RubyKaigi 19, Ruby 3 will ship with types for the standard library. This has been an ongoing, very successful collaboration where creators of other type checkers, Steep, RDL, us, and the biggest user of the type checker other than Stripe, Shopify, are having active discussions about how do we evolve the Ruby usage of types, how do we make it be Ruby and get the benefits that type languages normally get. It has been a great collaboration. It's a pleasure. Thank you, Matz. A lot of work has been done by Sutaro Matsumoto, who is the creator of the type checker called Steep, but he has also created their RBS, the syntax for type signatures that Ruby 3 will ship with. So thank you, Sutaro. Since we have open sourced, we have had in the open source, in the new repo that has been created for the open source, more than 800 pull requests. A lot of those pull requests are coming from not Stripes. We have 135 contributors who contributed to it. 10 of them are on the Sorbet team, either now or were before. 30 are Stripe engineers, and 85 are non-Stripe engineers. They are coming from Shopify, Coinbase, Heroku, CZI, all companies. It's a great collaboration. Companies are helping make it easier for people to adopt Sorbet, making it discover more errors that those companies care about. At this moment, we believe that tooling behind Sorbet, the tooling that those companies created together, can make it easier for you and pretty easy to adopt Sorbet and start getting benefits by it incrementally. Shopify will talk more about this, about what are the steps that they took and how did they benefit from it, and what are the problems that they ran through and what were the solutions for them. So it's the next talk in this slot, so please follow us. I wanted to specifically also pinpoint a few contributors. Alex Snaps has contributed parser support for Ruby 2.5 with the details about how to make it work correctly. And in tricky cases where parser of Ruby doesn't necessarily do what you would expect it to, Sorbet now does the correct thing. Ilya Bilic did the same for Ruby 2.6. Both of them are external contributors, and those are substantial contributions to Sorbet that they've done. Thank you, folks. Univario has built their way to automatically add documentation that comes from standard library and the gems to Sorbet signatures. In the examples that Jake showed you, where you had hover, the hover was coming from your code base. But similarly now, the information for hover can be coming from standard library. You will know documentation on pretty much every method in the standard library, on arrays, on hashes, on maps, all of those. This is awesome. Thank you, Univario. And we also have gem support. The Coinbase, while Stripe is a monorepo, and we mostly monorepo everything, not every company does it. In particular, Coinbase doesn't. So as an early user of Sorbet, they've built support for sharing type definitions for gems. Since we open source, 117 different gems have been added, additionally to the ones that Coinbase and Shopify were adding in bulk. Majority of the gems that people use now have types now, and those types are either auto-generated with tools that are part of Sorbet repo, part of similar tool that Shopify will present to Pioka, or part of the similar tool that Codebean built. We have automatic ways to gather type signatures to be shared, and then you can modify them and make them more precise to specify specific types. And majority of the contributions you hear are community. This is a very active project that helps better integrate Sorbet into the gems. If you're a library author, please join. If you're a library user, please join. You'll be getting all the features. You'll be getting autocomplete. You'll be getting hover. You'll be adding type checking. This is awesome. There are also entire projects that are extending and are building the ecosystem to make it easier for you to adopt. The most important one probably is Sorbet-Rails. This is a project that started by CZI, Chan Zuckerberg Initiative. An interesting thing about Stripe, Stripe uses Ruby, but we don't use Rails. Majority of the company in the industry do use Rails. Majority of projects do use Rails. So CZI created an external extension that makes Sorbet play really well with Rails. There's another project called Sort, which generates Sorbet types from yard annotations. So you have a code base where you used to describe majority of your arguments via yard docs. You can now convert them to Sorbet types in order for them to be checked. And Parlor is a general plugin ecosystem for writing Sorbet plugins so that you can teach Sorbet about your internal DSLs, about your internal coding conventions, about your internal magic that is adding additional benefit to your company, and you would benefit from adding types to it, despite it not being programmed by people. And now finally, this is all has been like us presenting our project as people who were working on it, so we can like make it look fancy. So we also want to add some direct feedback from the users of it. So here is one. I'll just let you read it through. So a very common thing that happens in a big code base is in order to make a change, in order to feel good about this change, you need to refactor some code around it. And as you're refactoring the code, you want to make sure that you don't break stuff. An iteration cycle through CI can be very painful for this and can make it so that you don't end up and you don't want to change things. And thus, you end up piling hacks and hacks. So here, the person is saying that Sorbet is making it easier for them to have faster iteration loop and thus to do refactorings and get it to a cleaner code base. Here, similarly, Stripe has a bunch of smaller code bases that do not have Sorbet. And it's very hard for people to like compare their experience pre-Sorbet and after Sorbet, because we're gradually rolling it out. But if you ever go to those other code bases that do not have the benefits, people see the striking difference between the two. We actually saw a lot of them start adopting it in smaller projects, simply because they're used to it and they enjoy the benefits. So yep, even in smaller projects, Stripe at this point are getting the types. And then, yep.
This was the email that we sent out the first day that we released Go to Definition. And I think Go to Definition was by far people's favorite feature. Like, it's completely changed the way that they write Ruby code, just because they don't wait for figuring out where something's defined. They just click, and they click, and they click, and then suddenly they understand the code.
Yep. This changes the iteration speed. That empowers engineers to be more productive, to be more brave, to do more experimentation, because they feel that they have better ways to check that they're still safe. This allows them to build more features, to change existing features, and do this in a code base that they now like. They like the abstractions that they introduce. They like that they can change them. They like that they can eliminate the abstractions that they no longer like. Now, the next question is, what's next? The major push from our team now is investing into the editor tools. We're investing in autocomplete. We're investing into jump definition. We're investing in final references. Increasingly, we're moving to things which, rather than asking questions about your code base, we'll be changing it, like refactorings. Doing refactorings automatically, like renaming a class, renaming a method, renaming a local variable, or like reordering local variables, maybe promoting a positional argument to a keyword argument or back. This is the majority of our investment. The second one is we want to make it even faster. Stripe code base is growing. And we want our users to continue having fast iteration cycle. From our experience, majority of the code base is similar to Stripe, grow at least cubically with time, if not exponentially, which means we need to continue making Sorbet faster, and this requires intentional effort. And then finally, we're hearing feedback from both internal users and external users, and ranking it by which one do we feel hear most commonly? Which ones will be the most useful for our users to invest in? And we've implemented multiple features that they asked for. We now have interfaces. You can specify that a module describes a set of functions, and you're required to always override them to implement them. You can have final methods. You can have final classes. You can have exhaustiveness checks. You can have sealed classes. A lot of those features that you would normally provide you guarantees are now possible and are being asked by users, and we're prioritizing them by the demand, both from internal usage and from open source. And then, again, to reiterate, There is going to be an awesome talk about how do you adopt Sorbet presented by Shopify after this one. It will be directly followed by this one. If you stay in this room, you'll see it. They will describe what problems did Sorbet solve at Shopify. They will describe what was the progress around solving them and what were the problems that they ran through and how did they solve them, so that you can learn from their experiences. Thank you for following our talks. We'd love you to share your questions, to share your feedback. If you haven't tried Sorbet, try it. If you have tried Sorbet, please let us know how did it go. We'd love to make it better. We'd like to improve it. Thanks to you for coming. As always, we're hiring. We'll be around. Thank you.
Also, I have stickers. Can we take questions? I'm happy to. We have like plenty of time. Is there like questions?
Yep. So the question was, we have this sig, the way you annotate the method with a signature, and it comes before the method. And the question was, how do we implement it? Jake, do you want to take this one?
Sure, yeah. So our syntax has gone through multiple iterations of design and redesign. And the actual concrete syntax, right, is sig is just a method name. And it's kind of hidden. I tricked you for the purpose of this demo, but there's actually a module very down here at the bottom called tsig. And if you include it into module, you can monkey patch every module. Alternatively, you can just put extend tsig in any class where you would like to use that annotation. And we did that for a long time. We required every Stripe developer to have this extension in every class that they wanted to use types in. And then we realized, wait a second, 80% of our classes have this in there, and it's just noise. So let's just get it and put it everywhere.
Yep. But to reiterate, this is just as a Ruby library. It runs on standard Ruby. It doesn't require any custom modifications. It's just a mix-in that you mix in, and now you have type signatures. Thank you for a great question. Yes, please. What do we use for? So the question was, what do we use for our VS Code hints? Sorbet implements language server protocol. Microsoft is popularizing this. It also works in other editors. We know for sure that it pretty well works in VI. We know that people who have successfully integrated in Emacs. But yeah, this is just a language server protocol integration, and yeah, it works. Thank you for a great question. Yep. So the question was, if you're somebody who's already using RDE, say RubyMine, what are the benefits of using this? RubyMine tries to understand your code base as written and to provide you some information, but it cannot do as much. It does not have the types. It tries to guess something, sometimes opportunistically. The difference here is when you're describing the sig, you're describing your intent. You're describing not what this method happens to do now, but what I want it to do. And you're describing that I want it to actually do this rather than anything else. So it provides you guarantees. If you're using IDE, like IntelliJ, you can still have autocomplete to some degree, much lesser case, and frequently it will be slower. IntelliJ is unreasonably slow in our code base. But if you have a small code base, maybe this is not a problem. But at the same time, the question is, how much of this can you trust? With Sorbet, all those signatures are 100% trustworthy. They're checked in production at Stripe. They're checked in tests at Stripe. They're fast enough for us to be able to run this in production. So they provide you guarantees rather than hopes. Hope is not a strategy. Thank you for a great question.
Yep, absolutely. Basically, I don't remember if Matz particularly covered this in this keynote, but at the RubyKaigi keynote in April or May or something like that, he basically talked about these 3 tiers of type checkers. So there's the Ruby core tier, and then there are like the things that are built right on top of Ruby core, and then there are like the third tier of like third-party checkers. And so the thing that they plan to ship for like the actual Ruby 3 release is type signatures for the Ruby standard library. And so Sorbet actually already has its own type signatures for the Ruby standard library. And so like when those are available, we will just like flip a switch, and suddenly we're using those, and that's no big deal. On top of that, Yusuke, who is giving a presentation after Shopify in this room, is going to talk about the second layer, which is like, we can't assume that all Ruby code, like literally every Ruby program, will be willing to adopt type annotations. So what can we do in the face of no type annotations? So he's going to talk all about his progress, like trying to come up with types for untyped programs. And then the third one, which is third-party checkers like Sorbet, like RDL from Jeff Foster, like Steep from Sotaro, are these kind of like things that will, in their own way, analyze the type signatures. So there will always be a place for Sorbet. It's just that we will be using either our own source of truth for the standard library or the Ruby source of truth for the standard library. And Sorbet will work the exact same way.
You can so the question was, can you support polymorphic interfaces, I guess? So if you specify a type and rather than taking a merge and you want to take something, first of all, we have OR and union types. So Jake is showing that you can say that you can. I'm actually intending to take either a string or a merchant, and we're going to be checking it correctly. Also, you can use mixins as an interfaces in your types. So we not only have classes in the type system, but also modules. Combining the two is the most common way we see people model the question that you're asking. Thank you for a great question. Do you want to take it?
Sure, that's a nice
question
to pass off. I think that the key design principle of Sorbet is actually the same design principle that makes it easy to adopt, because everything starts out in a code base without types, and so everything is untyped. And then over time, you add type annotations to it, and so they're added one by one. If there is a place where you realize, there is nothing currently in Sorbet's type system that will let me 100% accurately annotate this type, which does happen. There's sometimes that there's some method in the Ruby standard library that is just doing really wonky things. Either the first parameter is this, or the first parameter is this, and the second thing is this, and the types change all over the place. In there, sometimes you just have to say, OK, I can't type this, and say that it's untyped, and leave it at that. The thing that we've seen at Stripe, the thing that I think Shopify will touch on, is that you don't actually get, you don't actually need to type literally everything to get tons and tons of benefit. You can be OK typing the most common things and the most important things and having those things checked. And so if there is a conflict, they're rare enough that you can say, I'm just not going to worry about this.
Thank you for a great question. One downside that I saw from this is some people get super excited, and they end up mostly writing the types rather than the programs. We internally don't encourage this, and when it goes to a high degree, we discourage it, because types are there to help you. Types are not there to prove that you're smart. Types are not there to introduce complexity. Types are there to make it easier for other engineers. If you're writing a complex type that makes it harder for other engineers, that's not what they're for.
Kind of another thing that I've seen that gets people into a little bit of a trap is they trust Sorbet maybe too much. As you are incrementally adopting Sorbet in a code base, it will never be at 100% coverage, which means if you are assuming that the only thing that you need to ensure your correctness is the types check, then you might be bitten, right? You might be dealing with a gem that doesn't have type annotations yet, or you might be dealing with some older part of your code base that doesn't have type annotations yet. And so if you assume that the only thing that you're going to need to figure out whether it's correct now is the types, and say not rely on tests as strongly or not rely on careful monitoring as strongly, Sorbet is one more tool, right? It is not a replacement for existing tools. So
the question was, so far we're using nominal types. Do we see a future where we'll be doing structural types? So as this project has been progressing, this was one of the biggest questions that we were looking to answer. A lot of research that happened before us, most notably research by Jeff Foster, has showed that structural types, while they can model Ruby, the error messages this present are incomprehensible by people. For example, if you were expecting to have an integer and you got a float, the structural types will describe this as, here's 55 methods on integer, but I expected 55 methods in floats, and they look very similar. And as a user, when you're trying to compare them, it's very why are you complaining at me? They seem the same. So we chose nominal type system because of the user experience. Because by having classes, having modules, you're building a shared language between you and the type checker. The question was, can we type check Ruby code in this world? And empirically, yes. There are rare cases where somebody is asking for those. But most commonly, if we've seen this create more problems than solve it, where if you're doing this, you're also most likely having a method that has a short name. And there's somebody else happening to implement the method with a short name. So from our experience, we believe that it would be, at this point, potentially harmful to add it. It's additional work. It makes it easier to adopt in some cases. But at this point, our suggestion is just use untyped. Like this code path seems to be doing wonky things. It's not clear for us that you'll get as much benefits for having structural typed compared to just having untyped. So our suggestion is go with untyped. We're gradual. Thank you for a great question.
All right, I think we are at time, but I have nothing else to do but talk about types. So if you have any other questions for me, or Dmitry, we will be around pretty much the rest of the day and all of tomorrow. So thank you guys for coming.
Thank you for coming.